strict monotonicity of references has another relevant consequence about Pareto optimum. Right? Take any allocation X, which is a weak Pareto optimum. Consider the total consumption of this vector, of this allocation. This is simply the sum of the different bundles consumed by our H subjects. Consider the set T. You remember, the set T is the set of all the antipodes of goods which are producible by means of initial endowments of our households and by means of the technical processes of the firms. Question, where is this point? On the boundary, on the transformation curve, or below, like in this point? In other terms, if you have a weak Pareto optimum, there is some guarantee that the allocation of factors which permits to obtain these total quantities of consumption goods is efficient from a technical point of view. In this case, the answer will be no. However, it is easy to show that if individual preferences are strictly monotone, this is not the case. In effect, suppose that this point, which denotes, as before, the total consumption in the weak Pareto optimum, is not on the boundary. Now that tells there is another point, denoted by, say, Z. This Z now denotes a vector of produced quantities with all components less greater or equal to XHA with sum of XH and at least one greater. So it is possible to increase at least the available quantity of one good without reducing the quantities of all the other goods. In this case, in reality, all the goods are increased, but it is not necessary to suppose these. Consider the note by Z, it has used another symbol. X cap. Sorry, X cap. Consider now the difference between X cap and this sign. This is a non-negative vector, a non-null vector, because at least one component of this Z must be a positive number. And it is simply the difference between X cap and this sum. Now, simply redistribute this vector Z among the H subject. And you obtain another allocation with generic component YH. XH plus Z on H. If you compute the sum of this YH, you obtain sum of XH plus H times Z on H. Another simplification, you obtain sum of XH plus Z, which is nothing but X cap. So, the allocation, the vector, Y, with components Y1, H is a possible allocation. Because the total consumption bundles can be produced by means of a suitable distribution of factors among the different firms. But note that with respect to xk, yk, to xh, sorry, yh contains a higher quantity of at least one good, because z has at least one positive component, while all the other components are greater or equal to z. In conclusion, yh has all the components greater or equal to xh, and at least one component which is greater. By strict monotonicity, yh must be preferred to xh. So you have that the allocation y strongly dominates the allocation x, contrary to the assumption that x were a weak Pareto optimum. Contradiction. And the contradiction arises from the fact that we suppose it's absurd that this total consumption is below the transformation curve. I shall repeat also this theory. We are in a weak Pareto optimum with these components. The total consumption is given by the sum of these vectors. Clearly, it must be producible, so this total vector must be an element of T. The question is, this total consumption vector is on the boundary, on the transformation curve, or below? Because if it were below, this means that even if from an economic point of view, we are in an optimal situation. From the point of view of factor allocation among firms, there is no efficiency. There is no Pareto optimum of production, so to speak. Let's suppose absurd that this is the case. There is another vector x cap with all the components greater or equal than these, and at least one greater. Now compute the vector z, which is simply the difference between x cap and this sum. We obtain a non-negative vector, which has at least one positive component. Simply divide by h this vector z and redistribute among the consumer. And the subject will have a bundle yh, which is equal to the original xh, plus 1h of z. In other terms, you are adding to the vector xh a positive quantity of at least one good without reducing the quantity of any other good. But this means that yh is preferred to xh by strict monotonicity. Last step, if you compute the total quantities of goods you have in y in this sum, clearly you obtain exactly x cap. Quindi, therefore, this vector is a possible allocation, because the sum of the components of y is an element of t. But this is a contradiction, clearly, because we initially assumed that x was a weak Pareto optimum. And here there is another allocation which ameliorates the condition of all subjects. Impossible. And therefore, economic efficiency implies technical efficiency. The total produced and consumed quantities are on the transformation curve. And with this result, we concluded the analysis of Pareto optima. The most important part of this analysis are the theorems of welfare economics. We shall see them in another lesson.